These are the solutions for the study guide for quiz number 27. So we're going to end up having to simplify these fractions first, the first four problems. And so what I'm going to look for are common factors. And I don't see any common factors between the terms, but I do see a trinomial that will factor as two binomials. So I'm going to keep the numerator the same and then factor the denominator. And the way the denominator factors is a b plus 4 and a b plus 5 or b plus 1. I knew that because 4 and 1 multiply to make 4. In the outside terms, the 1b and the 4b add to make 5b. So what I can do from this point is cancel out the b plus 4s, and when you do that, you get a number 1. And so when you divide a number into another number that is the same, it just makes 1. So my answer is 1 over b plus 1. You can't do anything with the two 1s there because it's not really 1 in the denominator, it's 1 more than b. So they wanted the excluded values as well, so what you're looking for are the numbers that make 0 in the denominator. So I just take b plus 4 and set that equal to 0. b plus 1, set that one equal to 0, and you just do opposite operations. And so what I'm left with is a b equals negative 4, two minus signs in there, b equals negative 4, and a b equals negative 1. So those are the excluded values, so I can't have those, so I'm going to put an equal sign with a slash through it to represent the excluded values, the values that b cannot be. So in this next problem, I see two trinomials, so I'm going to factor both of those trinomials first. And I knew this was a positive 7 because I had more positives than negatives, and those two outside-inside terms do subtract to make 4. The denominator, it's a positive 6 for the last term, so I know both sides are negative, so it's t minus 3, t minus 2. So now I can go ahead and take out those common factors of t minus 3. And so what's left over is the t plus 7 on top of the fraction and a t minus 2 on the bottom of the fraction. So that is the simplified form. The excluded values are the values that make it 0 in the denominator. So the two numbers that will not work would be 2 and 3. So I get those by just putting, if I do a 3, 3 minus 3 makes 0. And if I did a 2 right here, 2 minus 2 ends up making 0. So that's why I cannot have those two numbers, because I cannot have 0 in the denominator. So you'll see this situation where this is in ascending order. It goes from the constant to the variable term. So typically when that's the case, they'll put a minus sign in between. That's why they ended up putting it that way, so it doesn't look like negative 2r plus 7r, or 10r, or just 10. But it's the same thing, negative 2r plus 10. So they do this so that they have less things to write. They don't have to write the plus and the minus sign. They can just write one term. So when that's the case, you're going to want to take out the common factor, which is 2, but take out the negative sign as well. And that will switch the variable term to a positive inside the parentheses. And so I have a minus 5, r minus 5 down below. And the reason why is this way you can get those terms to cancel. So here I have a difference of squares, so it factors to r minus 5 and an r plus 5. And then I can get the r plus or minus 5s to cancel out. And so what's left on top is negative 2 and an r plus 5. And we want the excluded values, and the two numbers that r cannot be would be 5 and negative 5. So the numbers that will make 0 in the denominator. Let's take a look at the next three problems. And on this one, they ask us to multiply. So on this problem, where there's no addition signs, what I would do is just use the commutative property. So take the 3, the 5, count up how many x's you have. You got 3 x's here, 2 here, and 1 here, and count up the y's. You got 2 y's on top of the fraction. Now down below, rewrite the two coefficients, 2 and 9. Don't multiply them, because then the reducing becomes a little bit more difficult. And then write the x's, and then write the y's. And so now go ahead and cancel. So now you'll see how the y's all cancel out. You'll see how 3 x's cancel out 3 x's on the bottom, leaving me with 1 x on the bottom. So this time, I've canceled out the y's, but I have an x left. So I'm going to put that in the bottom of the fraction before I forget about that. So now I'm going to go ahead and look at the coefficients, and I see that this 3 will go into 9 3 times, so that's all I can do. And so what's left on top is a 5 and the 2 times 3, which just makes 6. So there's your answer. So 5 over 6x. So moving on to the next one, now I have addition signs. So in order to factor this, I need to go ahead and take out the common factors. So I've got 5m to the second power I can take out from these first two terms. And what's left over is an m plus 2. Keep on working on the top of the fraction, right? There's one big fraction bar here. And go ahead and take out any common factors, but I don't see any, so I do see a difference of squares, so it factors to an m minus 3, m plus 3. So when it is a binomial, and one term's a perfect square, the other term is as well, it'll factor as that. Two binomials, both same numbers, but just opposite signs. So they call this a sum and a difference. In the denominator, there's a common factor of 6m, and I can go ahead and do that reducing or taking out that common 6m, and I've got m plus 3. And I've got a trinomial, so that's going to factor to m plus 2 and an m plus 1. And so now I'll go ahead and take out the common factors. So I see the m plus 2's are going to cancel, m plus 3's, and I see this 1m is going to take out one of the m's on top of the fraction. But that's all I can do. So I look to see what's left on top, and I've got a 5 and an m minus 3. Down below I've got the 6 and the m plus 1. It's a common mistake to cancel out the m's, but you can't do it because it's not really m on top, it's 3 less than m, not m on the bottom, it's 1 more than m. And so that's the way I'll leave my answer. Now sometimes you might see this multiplied out, so it could end up being 5m minus 15 all over 6m plus 6. So either way would be okay. I would take either answer. So on this one, I go ahead and factor the numerator. And so this is going to factor as a sum and a difference, x minus 3, x plus 3. I'll go ahead and do the denominator as well right now. This makes an x minus 3 and an x plus 2. Numbers that multiply to make negative 6, subtract to make 1. Now, the reason why I didn't extend this fraction bar quite yet is because it's division. I've got to multiply by the reciprocal. So I'm going to put this fraction on top and then go ahead and factor it. So it factors to a 2x and an x here, and then I need numbers that multiply to make 3. They need to be the same sign because they multiply to make a positive 3. Now I know they're both negative because the outside and inside terms add to make a negative 7. So I'm going to try 3 here and 1 here, and that works out because this makes 6x and 1x add to make 7. So now I see 4 and 36. So before I know they're perfect squares, so it's going to factor to a sum and a difference, but there's a common factor. And so I'm going to take out that common factor first, and it's 4. And so when I do that, I've got x squared minus 9. So I'll go ahead and cross this off. So I saw that it's going to factor twice, but I want to make sure that I end up getting the correct factoring, and it factored completely. So 4 is going to go on the outside. Now I'll go ahead and factor this x squared minus 9. It factors to x plus 3, x minus 3. And I had one of those earlier, and it was on top of the fraction, so those are going to now cancel. And so the x minus 3 and the x plus 3 will cancel out this x minus 3 and this x plus 3. This x minus 3 will cancel out this x minus 3. And it looks like all I've got to do. So I look to see what's left over, and I've got a 2x minus 1 on the top of the fraction. I got the 4 and the x plus 2 on the bottom of the fraction. And so I'm going to write it this way. Typically we write the numbers, the constants, or the coefficients first. And so I'll put that in front of the parentheses. So again, you could see it this way, or on some tests you might end up seeing it this way, 4x plus 8. And so that would, either answer is fine. So let's take a look at the last 3 problems, and they're adding or subtracting problems. So the first one you see has a common denominator already. So all you're doing is just counting up how many terms you have in the numerators together. And I can combine these because they have the same variable terms. So I've got 3m squareds and 11m squareds make 14m squareds all over 8. And so I'm just taking out the common factor now. So I see that I can divide them both by 2. And so what that leaves me with is the 7m squared all over 4. And that would be my answer. On this one, I almost have the same denominator, but not quite. So I need to multiply the left-hand side by x minus 2 over x minus 2. the right side by x plus 2 over x plus 2. So I have to use FOIL when I multiply out the two binomials. So I get x squared and then a positive x, a minus 2x, and a minus 2. And then on this part, I've got to use the distributive property. So I get a positive 3x and 6x, or just 6. 3x and 6. Now in the denominator, I'm going to write this in the factored form, x minus 2, x plus 2. The reason is that when I go ahead and collect like terms, I might be able to reduce. I might be able to factor this and cancel out one of these factors. So x squared cannot combine with anything. I count up the x's at 1, negative 2, and 3. So that ends up making negative 1 plus 3 makes positive 2x. And then negative 2 and 6 end up making a positive 4. So this does not factor. Numbers cannot multiply to make 4 and add to make 2. So I will leave it in this form. X squared plus 2x plus 4 over x minus 2x plus 2. You can factor out the denominator, or multiply out the denominator, but it's not really necessary. I would just leave it in this form. So on this next one, it's a subtraction problem. And so with subtraction, make sure that you add the opposite before you do anything else. So both of these terms have to switch sign. So they both switch sign there. Now I'll go ahead and come up with that common denominator. So I see that this side needs an x minus 2, and this side needs a 3x. So I'll go ahead and use the FOIL method once more. So I've got x squared plus 3x minus 2x minus 6 when I multiply out these two binomials. Now on this one here, I've got a negative 6x squared and a negative 3x. So that's why it was so important to make sure that I add the opposite of both the terms to get the signs correct. So I draw the big fraction bar and rewrite the 3x and the x minus 2. So now I'll collect like terms. So I see that I've got a negative 6x squared and a x squared. So that's going to give me a negative 5x squared. And I look at the x terms. I've got a 2x negative, or 3x negative 2x makes a 1x, positive 1x there. And then I've got this negative 3x. So that gives me a negative 2x. And then the last term left over is negative 6. And it's all over 3x and x minus 2. So in this one, again, you can look to see if you can factor this. Now, if I was to factor it, I would take out the negative first, and that would leave me with 5x squared plus 2x plus 6. And then when I go ahead and try to factor this, I'm not going to be able to do it. I see it right away because all terms are positive, so that means the outside and inside terms would have to add to make 2x. And you can't get anything to multiply by 5 to add to make 2. So that's not going to end up working out. So this is as far as we can take the problem. So again, you can multiply out the 3x and the x minus 2, but it's not really necessary. Typically, we'll just leave those in the factored form. So those are the solutions to the study guide for quiz 27. Good luck.